Overview of cloud computing. I am Dr. Rajiv Mishra as a professor, Department of Computer Science and Engineering, Indian Institute of Technology, Patna. In this particular overview, what we are going to cover is about the brief introduction of a cloud computing that becomes the background with the focus on aspects of today's cloud. Then we will talk about the cloud computing from previous generations of distributed systems, brief history, current demand of cloud data center, features of cloud computing, private and public cloud are some of the topics which we are going to discuss in this particular lecture as part of the overview of cloud computing. Now, let us trace the hype of cloud which has grown to this stage of today's cloud. Now, forecasting agencies Gartner in 2009 forecasted that cloud computing revenue will soar faster than expected and exceed $150 billion by 2013, and this will represent 19% of IT spending by 2015. IDC forecasted in 2009 that spending on IT cloud services will triple in next 5 years and reaching $42 billion. Forrester in 2010 forecasted that cloud computing will go from $40.7 billion in 2010 to $241 billion in 2020. Now, based on these kind of hypes, there is a complete trend that industry is spending so much of money in IT cloud services, and which has resulted in the growth of cloud computing. Companies and even state governments are also started using the cloud, which has resulted into this today's cloud. Now, let us see about the cloud that will give a scalable computing over the internet. So, evolutionary changes have occurred in distributed and cloud computing over last 30 years, which are now driven by the applications and variable workloads and the large data sets. These are some of the challenges or the requirements of today's cloud, which has changes from distributed and in the cloud computing scenario. Now, these evolutionary changes have been made in the machine architecture, operating system, network connectivity, application workloads. So, therefore, distributed computing system uses now multiple computer to solve large scale problems, and that too over the internet. So, distributed computing becomes data intensive and network centric over this particular internet based scalable computing. Now, the emergence of computing cloud thereafter increases instead demands high throughput computing systems built with distributed computing principles. So, high throughput computing appearing as computing clusters, service oriented architectures, computational grids, peer to peer networks, internet clouds, and future internet of things. So, these are some of the precursors from distributed computing to the current stage of scalable computing over the internet, which is also now has grown into the cloud computing parlance. Now, with this little background, how from distributed computing it has grown to the current cloud computing. Now, this particular cloud computing is being provided by different companies, and they are called cloud providers. So, the prominent cloud companies are Amazon Web Services, Microsoft Azure, Google Compute Engine or App Engine, RightScale, Salesforce, EMC, GigaSpace, Tengen, Oracle, VMware, Cloudera, and 100 more companies are having the presence as the cloud providers. Now, with this cloud computing, the customers often save time and money both. For example, with AWS, a new server can be up and running within 3 minutes compared to even 7.5 weeks to purchase and deploy the server internally in the form of a 64 node Linux cluster. can be running in a online mode in 5 minutes internally. With the online services, this will reduce the IT operational cost by roughly 30% of spending. So, the private cloud of virtual servers inside data centers has saved nearly crores of rupees annually, because the company can share the computing power and storage resources across the servers. Thereby, there is a possibility of saving time and money both from the customer's perspective. Hundreds of startups can harness this large computing resources without buying their own machines. In this way, customers save time and money both. Now, this particular cloud computing, which often allows sharing of computing resources across multiple customers, resulting into the saving of time and money. Deals is being provided with the help of a technology which is called the virtualization. So, virtualization has brought the benefits of the cloud computing, that is, to the customers time and money and time both savings. So, let us understand about what do you mean by the virtualization and how is it giving up the cloud technologies, cloud computing technologies. So, virtual workspaces, that is an abstraction of an execution environment that can be made dynamically available to authorized clients by using a well defined protocols. Now, it provides the resource quota, that is in the terms of CPU memory share, then software configuration. Now, this particular virtual workspace is being also facilitated using virtual machines or VMs. So, VMs are nothing but an abstraction of a physical host machine, and the hypervisor intercepts and emulates the instruction from VMs and allows the management of virtual machines. Now, important hypervisors are VMware, Xen, etc. And it provides an infrastructure which is supported by an APIs and plug in to the hardware or the software resource. So, let us see here in this particular stack. Here you can see this is the hypervisor and this is the hardware, and this entire thing is called virtualized stack up to this point. Now, when you talk about the virtual machines, so this part which contains the operating system and the applications running is called the virtual machines. So, virtual machines are this particular box. So, you can see here you can form 3 different boxes. So, you can say that there are 3 different virtual machines are running on top of the hypervisors. This is the hypervisor. So, if you see this particular virtual machine, so it becomes an abstraction of the physical host machine. So, you can see that this particular application is running on its own operating system, the other application is running on another host operating system, and all these 3 different virtual machines will become an abstraction of a physical host machines. Now, here you can see that to support 3 different abstraction of physical machines, it requires something which is called an hypervisor. So, hypervisor intercepts and emulates the instructions which are coming from these virtual machines, like here. For example, there are 3 different abstractions. This is one, this is second one, and this is third one. So, they are being intercepted by the hypervisors, and then allows the management of these virtual machines, sharing this particular hardware across these virtual machines. So, this particular prominent hypervisors are VMware, Xen, etc. Now, this particular hypervisor, they provide the infrastructure APIs and that can be plugged into the hardware and support system. Now, let us go in more details. Over here is that virtual machine technology allows multiple virtual machines to run on single physical machine. Here that example is shown over in this particular slide, that you can see that this is the hardware, this is one piece of hardware, there is one physical machine, or you can also say this is a single physical machine, and this particular single physical machine is being shared by 3 virtual machines that you can see. This is the virtual machine number 1, this is virtual machine number 2, and this is another virtual machine 3. So, there are 3 different virtual machines, they are sharing the same hardware, and that is being facilitated with the virtual machine technology, which is called virtual machine monitor, or it is also called the hypervisor. Now, let us see what are the advantages here of virtual machines. So, virtual machines, if you see in the previous figure, virtual machines, they have their own guest operating system, and this guest operating system runs multiple applications. So, advantage of virtual machine is that it will run operating system where physical hardware is unavailable. So, only the virtual form of hardware is being presented, or let us say that many virtual machines which runs their own operating system without any physical hardware is allowed by the virtual machines. Now, another advantage of virtual machine is easier to create new machines and backup machine, etc. Another advantage forms about software testing using clean install operating system, and software emulate more machines than physically available, timeshare lightly loaded systems on one host, debug problems, suspend resume problems, easy migration, and run legacy systems. Now, with this little background of a cloud and the use of hypervisor, now let us understand what is a cloud. So, the advances in virtualization makes it possible to see the growth of cloud as a new computing paradigm. So, dramatic difference between developing the software for billions to use as a service versus distributing software to run on their PCs was being realized with the help of a cloud. So, let us trace back the history to understand what is a cloud. In 1984, John Gage from Sun Microsystems said for the cloud that network is the computer. In 2008, David Patterson of US Berkeley said the data center is the computer. Recently, Rajkumar Bhaiya of Melbourne said the cloud is the computer. Now, some people view clouds as the grids or clusters. With changes through virtualization, since the clouds are anticipated to process huge data sets generated by the traditional internet, social networks, and future IoT. So, the cloud can be a single site cloud, which is also known as the data center, often comprises of a computing nodes, often grouped into the racks, that is shown by this red arrows. Then in a single site cloud, not only compute nodes which are grouped into the racks, but it also has the switches which can connect across different racks, that you can see the switch which is connecting 3 different racks and which is also called top of the rack switch. Then it has the topology, that is network topology of all that networking devices, that is top of the rack switch is all connecting the servers, or the racks are often connected together with the help of a core switch. Then it has the storage of, that is the back end nodes connected to the network. Then it has a front end for submitting the jobs and receiving the client requests, and this entire thing is often called as 3-tier architecture, and it runs the software services. That was a single site cloud in the cloud, and it is also called the data center. Now, another thing is there inside cloud or to understand the cloud is that it is a geographically distributed cloud, which consists of multiple such site or a multiple single site cloud, and each site perhaps with a different structure and the services together is called geographically distributed cloud. Now, cloud computing overlaps with distributed computing. As you know that distributed systems are a precursor to the cloud. So, they often overlaps with the cloud computing overlaps with the distributed computing in that sense. So, distributed computing in distributed system consists of multiple autonomous computers having their own memory communicating through messages, that is the simple form of distributed system which gives into the distributed computing paradigm. Whereas, the cloud computing, the clouds are built with the physical or the virtualized resources over the large data centers that are nothing but a distributed system. So, cloud computing is also considered to be a form of utility computing or the service computing. So, if you can see the difference, that distributed computing is nothing but the distributed systems, where you can see that the autonomous computers which are connected with the network having their own memory, they often communicate with each other using the messages or a message passing. So, message passing system which is being used to communicate across the multiple autonomous computer forms a distributed computing. Similarly, as far as the cloud computing is concerned, so the clouds can be built with the physical or the virtualized resources over the large data centers that are distributed systems. So, this particular entire distributed system, when it is virtualized, it will give a virtualized resources, and that are nothing but they are built with the large data centers and often virtualized. So, cloud computing is also considered to be in that way the form of utility computing or the service computing. So, a cloudy history for a cloud computing, let us trace back the history of the time. It started with the first data center, and then you know that it is a large system in 1950s, and they were also called initially it is a data center. Then comes the time sharing systems in 1970s, 1980s, it forms into the grids and the cluster computing, and then in 2012 around that time it became the cloud data center. Before that it was also called as a peer-to-peer system. They are all precursors to the cloud data center or peer-to-peer system, grid and clusters, time share systems and the first data centers. And again the wheel has come to the same point where it became the cloud data centers. Now, if we see the scalable computing trends, that is the technology. So, there you can see that the storage is doubling every 12 months on the same cost, bandwidth every 9 months and the CPU compute capacity every 18 months, and this is called the Moore's law, indicates that the processor speed doubles every 18 months. Gilder's law indicates that the network bandwidth has doubled each year in the past. Then and now the bandwidth earlier in 1985 was mostly 56 kilobytes nationwide, and now in 2015 you can see that this particular backbone has become terabits per second from kbps. Similarly, it has the disk capacity, that is today's PCs have terabytes for more than 1990s supercomputer. So, the trend towards utility computing is that aiming towards autonomic operations can be self-organized to support dynamic discovery. Major computing paradigms are composable with quality of service and service level agreements. In 1965, MIT's Fernando Corbato of Multics operating system and envisioned a computing facility operating like a power company or a water company, that is the utility computing. Plug your thin client into the computing utility and play intensive compute and communication application. Utility computing focuses on the business model in which the customers receive the computing resources from a paid service provider. So, the characteristics of cloud computing, some common characteristics is that it is having a massive scale, it is having the homogeneity, and then virtualization, low cost software, resilient computing, geographic distribution, service orientation, and advanced security. Now, essential characteristic is that on demand self service, broad network access, rapid elasticity, resource pooling, and measured services are some of them. So, now let us go inside of all that. They are called the features of today's cloud, and they are all divided into 4 different categories to understand all the features of today's cloud. The first important feature is called the massive scale in today's cloud. So, what do you mean by the massive scale? It is nothing but a very large data centers contains tens and thousands and sometimes hundreds of thousands of servers, and you can run your computation across as many as server as you want, as many as server your application will scale, and that huge infrastructure which is providing the application which requires the huge infrastructure together is called the massive scale in today's cloud is important feature. Another important feature is the second important feature is called on demand access, pay as you go, no upfront commitment, that is anyone can access it. Third important feature of cloud is data intensive nature. What megabytes has now become terabytes and petabytes and zettabytes. For example, daily logs, forensics, web data are a very large, or they can also be rated as the big data. So, this kind of big data or huge amount of large scale data and requires the computing called data intensive nature of computation is one of the important feature of today's cloud. Fourth important feature is that new cloud programming paradigm, that is MapReduce, Hadoop, NoSQL, Cassandra, MongoDB, and many others. So, combination of one or more of these gives rise to novel and unsolved distributed computing problems. Now, let us understand about the massive scale from the cloud provider's perspective. So, Facebook, you can understand the Facebook in 2012 has 180K number of servers. Similarly, Microsoft uses 110,000 machines at 4 different sites to run the application that is called Microsoft Cosmos. Similarly, Microsoft Bing requires 80,000 running systems. Yahoo in 2009 uses 4,000 different clusters, split into 4,000 different clusters of 10,000, 100,000 machines. AWS EC2, that is in 2009 uses to run on 40,000 machines of 8 cores. Similarly, eBay in 2012 uses to run 50,000 machines. HP 2012 uses 380,000 in 180 different data centers. Google has a lot. So, this is the size which is called massive scale. If you look inside the data center from that perspective of scale or the size or the massive scale, that you can see that these are in the figure you shown, they are nothing but they are called the racks. The room which is filled with the racks, and the rack is filled with so many number of servers, and all are connected with a 3-tier hierarchy network topology, and they are all connected together, you can see over here. Now, this entire massive data center having hundreds of thousands of computer requires huge power and energy. So, their power usage efficiency is a metric which will tell PUE PUE is called power usage efficiency. So, power usage efficiency is total facility power divided by an IT equipment power. So, low is good. So, Google says that it is achieving 1.11, that is power usage efficiency. Similarly, water usage efficiency, water is used to cooling for cooling purposes. So, the efficiency here is water usage efficiency is nothing but the annual water usage divided by IT equipment energy. So, lot of cooling technologies are involved in the data center. Now, coming up, the second important feature of a cloud, today's cloud is called on-demand access. So, on-demand access is also called as a service classification. So, as a service classification, here it is shown as the cloud application, that is starting with the cloud infrastructure as a service. If you see cloud infrastructure as a service called IaaS. So, cloud infrastructure as a service, that is being provided in the form of virtual machines, and this is being achieved with the help of having lot of servers with the cloud providers, storage, load balancer and network. Together it provides virtual machine, and this is called cloud infrastructure. The second sophisticated service than infrastructure service called platform as a service, that is PaaS. So, there it provides the development tools or the environments instead of dealing with the virtual machines. Now, beyond this, there is another type of as a service called software as a service. So, there the application services are being provided, and that is not even dependent upon virtual machines or a platforms, but directly the services, for example, Gmail, virtual desktop, CRM and so on. So, you can see that when you say an on-demand access, so you have to now compare it in terms of buying or renting as a service like cloud. So, AWS is one such service which is called elastic compute cloud. A few cents to a few dollars per hour CPU usage is being measured. Similarly, AWS simple storage service S3 is a few cents per GB month. Hardware as a service, infrastructure as a service, that is get access to the flexible computing storage infrastructure. Virtualization is the technology which provides infrastructure as a service. Examples are Amazon Web Services, AWS. EC provides two different type of infrastructure as a service. EC2 is a elastic compute cloud is a compute service, and S3 is a simple storage service, that is a storage as a service. Platform as a service get access to the flexible computing and storage infrastructure coupled with the software platform. Example is Google's App Engine, which provides the platform as a service for Python, Java and Go platforms. Software as a service, SaaS, get access to the software services when you need them and subsumes the software as a service architecture. Examples are Google Doc or an example of a software service. Now, if you see the service versus description, what you will find is that infrastructure focus is there, hosting, storage and platform. That is, hosting means that physical data centers which are run by the presence of different companies like IBM, HP, Google, Microsoft and so on. Storage means data storage or a cloud based NAS. Platform is the platform such as cloud based platforms provided by virtualizations, as we have already told. Application focused services, applications and development are we have already seen that in the previous. Now, the next feature of a cloud is data intensive computing. So, computation intensive computing we have already seen earlier days, like called MPI based high performance and grid computing, and supercomputer was called often the computation intensive computing. But now we have moved to another era of computing, which is called data intensive nature of computation. Typically, it stores the data at the data center and use the computing nodes nearby. So, why the data is too huge, it cannot move where the compute nodes are, but rather the compute nodes, if it is being available near to the storage places, then it is a possibility, and it is called data intensive nature of computation. So, the compute node runs the computation services. Now, in a data intensive computing, the focus shifts from computation to the data. Now, CPU utilization no longer the most important resource matrix. Instead of here, the input output is also very important, such as disk and the network. Finally, the next paradigm, next feature of a cloud computing, today's cloud, is called new cloud programming paradigm. Easy to write and run highly parallel programs in a new cloud programming paradigms, such as Google provides MapReduce and Souzal, and Amazon provides Elastic MapReduce, a pay as you go by model. Now, Google MapReduce provides indexing as a chain of 24 MapReduce jobs, around 200,000 jobs they are being processed with 50 petabyte per month in 2006. Yahoo has Hadoop and Pig together. Facebook has Hadoop and Hive, and NoSQL is MySQL is an industry standard. But Cassandra, you can see, provides 2,400 times faster using this new cloud programming paradigm. Now, there are two categories of clouds. First is called public cloud, the other is called private cloud. Private clouds are accessible only to the employees. For example, popular vendors for creating the private clouds are VMware, Microsoft Azure, and Eclipse. Public cloud are being provide the service to anyone who can be a paying customer. Examples of a public cloud services include Amazon AWS EC2, Google App Engine, Gmail, Office 365, and so on. So, if you are starting a new company or a startup, you should use a public cloud or purchase your own cloud. So, this particular decision has to be made. Single site cloud, to outsource or to own. Let us understand this particular decision or a question. Consider a medium sized organization that wishes to run a service for a month. Now, that service which medium sized organization wishes to run requires 128 servers for that application, and it requires 1024 cores and 524 terabytes. So, let us see that if that organization decides to outsource via AWS service, let us consider the monthly cost. Now, for the storage, AWS charges S3 cost as $0.12 per gigabyte month, and EC2 cost is $0.10 per CPU hour. So, let us see about the storage, how much costs for requirement of the storage, that is 524 terabytes multiplied by 1000, because it is 0.12, rate is $0.12 per gigabyte month. It comes out to be $62,000. Now, calculating the CPU hour. Now, the CPU time is given as 0.10, and it requires 124 different cores, and it requires 24 multiplied by 30, 24 hours and 30 days. It comes out to be $136,000. That is, if it outsources on a monthly basis. Similarly, to own that, that means if the organization is going to purchase it, what is the monthly cost? Works out to be for the storage is $349,100 divided by m months. That comes out to be total of $1,555,000 divided by m months plus 7.5 K. That includes the system administration cost. Considering that the split for hardware, power and network and 3-year lifetime of the hardware. Now, let us see calculate the break-even analysis, more preferably to own if $349K divided by month is less than $62,000 for storage, and for similarly for this one CPU infrastructure, that is 1,555K divided by m plus 7.5 K if it is less than $136,000 overall. So, break even comes out to be if m is, that is m is greater than 5.55 months for storage and m is greater than 12 months overall. So, that means if medium size organization wishes to use the storage for more than 5.55 months, then it is better to own that. It will be break even cost analysis says it. Similarly, if m, that is the number of months, is more than 12, then it says that overall system has to be now better, overall system has to be now procured and use it. So, most of the startup companies uses the cloud a lot because it is break even point comes out to be less than a year, and the cloud providers then benefit monetarily most from the storage. So, conclusion, we have covered the following topic in this lecture. We have given the overview of cloud computing, then cloud computing versus the previous generation of cloud, that is nothing but a distributed computing. We have given brief history and the current demand of cloud data centers, various features and characteristics of cloud computing, on demand cloud computing with private and public clouds. Thank you.